Which of the following is the graph of y equals 3 times the secant of 2 x minus pi over 2 plus 2? So this is a pretty complex transformation of the secant function. We have a vertical stretch, we have a horizontal compression, all right, so the period is changing. We have a horizontal shift and we have a vertical shift. So there's a lot going on. So let's just take it step by step. I think I'll start with what we call the B value. Okay, normally we refer to this as the A value, which tells us the amplitude, well, when we're dealing with sine and cosine. And this is the B value. Now the B value is important because it affects the period. Okay, so here is a little formula that I want you to write down. For sine, cosine, secant, and cosecant, the period is always going to be 2 pi divided by the B value. So in this case, the period is going to be 2 pi divided by 2. So that means that the period is going to be pi. So let's use that information to eliminate some of these graphs if we can. So we're only going to consider graphs that have a period of pi. So that means from corresponding point to corresponding point, all right, that has to be the same as pi on this graph. So those look about the same, so I can't eliminate that graph. Okay, so from corresponding point to corresponding point, okay, that looks about the same. All right, can't eliminate that graph. Okay, I can eliminate this, all right, from corresponding point to corresponding point. All right, that's the period of this graph. And here's pi right here. Okay, so this graph is definitely not our answer. So we've eliminated one. Okay, it's the same deal here. Corresponding point to corresponding point. Look at that period. Okay, that's a period of actually 2 pi instead of just pi. So we can eliminate this option. So far we've narrowed it down to a 50-50 chance between these two graphs. Let's see if we can eliminate any more choices using some of these other transformations. Okay, next let's look at the vertical shift. All right, because of this 2, all right, that means this should be the midline. Okay, the midline should be 2. Okay, so let's see. 4, 8. Okay, so this should be the midline right in here. Okay, that's a really crooked line, but that should be the midline, and this should be the midline right here. Okay, I don't think that helps us eliminate anything. All right, both of those look accurate. All right, so what does that leave? Okay, it's time for the phase shift. Let's use the horizontal shift. So on the inside of the function, this is always going to be a shift that's either left or right. And it's going to be the opposite of what we would normally think. So we normally think of left as being negative, but guess what? It will actually be left if it is positive. And it'll be to the right if you're looking at a negative number. So because this is minus pi over 2, that means this is actually a shift to the right by pi over 2. Okay, so one of these two graphs is shifted to the right by pi over 2. So I think we need to sketch a graph and then imagine what it would look like if we shifted it to the right. So let's sketch a graph. Okay, remember that the period is not 2 pi. It's the period is just pi, so we need that information. So if I go to the right, here's pi, and then this would be pi over 2. Okay, and then we'll put a couple more marks in between. So the secant function is the reciprocal of cosine. So this is the same thing as 1 over cosine. So that's why I'm going to graph a cosine function right now. Okay, and this is 1, and this is -1. So a cosine function would go like this. It would start at 1, it would go down through here, it comes back up. Alright, this is what the cosine function would look like. We've learned that there are asymptotes everywhere cosine touches the x-axis. So there's an asymptote right here, and there's an asymptote right here. Okay, you know what? I think I need to keep this going a little bit further. So I will go ahead and do -pi as well. Okay, so this would be like pi over 2. Alright, and I'll put a couple more marks down. So I'm just going to continue my cosine function, which would look like this. Okay, and again, there should be asymptotes everywhere cosine touches the x-axis. So there should be an asymptote here and an asymptote here. Alright, now we're ready to graph the actual secant function. Because the secant function touches the tops of these hills and the bottoms of these dips. So I'm going to have a secant function. I'm going to have a little loop of the secant function here. And I'm going to have another loop here. Okay, and I would have a loop here. Alright, I know this is complicated, but I don't see a way around it. Alright, so now, let's imagine shifting this graph to the right by pi over 2. Okay, so on this graph, that would mean shifting it 2 marks to the right. So everything would be shifted 2 marks to the right. So if I shifted this, for example, 2 marks to the right, pi over 2, this was -pi over 2, by the way. If I shifted this to the right, pi over 2, then I would have a loop here. Okay, I feel like I need a different color. I'll go ahead and use purple, even though I use that for my asymptotes. It's okay. So if I shifted this to the right by 2 marks, then I would have a loop right here. Alright, if I shifted this to the right by 2 marks, then this upward facing loop would be here. So basically everything is moved over, okay, to the other side of the asymptotes. Alright, so I think these 2 loops are going to be enough for me to see what the graph is doing. Alright, so just so you can focus a little bit better, I'm going to erase this. Okay, so look at these purple loops that we just made. I'm looking for which one of these two graphs matches this. Okay, so the easiest one to spot is I should have a downward facing loop right on the y-axis. Okay, there should be a downward facing loop right on the y-axis. Okay, so when I look at these two pictures, I see right here I have a downward facing loop right on the y-axis. Alright, when I look at the other picture, there is no downward facing loop right on the y-axis. Okay, so that tells me that the very first picture is going to be the answer. Okay, so I know that was a little involved and complicated. You might need to watch this video again to fully understand everything that we did. There was a lot going on.